Okay, in this video we're going to discuss how rates of change can be applied in the real world, and we are going to look at an example of the movement of some particle. So what we have is a position of that particle function. The position of the particle is given by this function t cubed minus 12t squared plus 36t. T is seconds, s is in meters. That would give us the position of wherever that particle is at any given time. First thing we want to do is find the velocity. So now that we know how velocity and position are related, we should know that the velocity is simply just the derivative of the position function. So if we take the derivative of the position function, I get 3t squared minus 24t plus 36. Find the velocity after 3 seconds. I would simply just do v of 3 and if we evaluate that, we get negative 9 meters per second. When is the particle at rest? So the particle at rest would mean that the velocity function is equal to 0. Right? So that's not happening at time 0. It could be happening at time 0, but we want to know when the velocity is 0. So what I'm going to do is I'm going to take the velocity function, 3t squared minus 24t plus 36, and I'm going to set that equal to 0. So the first thing here I would do is factor out a 3, which would give me t squared minus 8t plus 12. And then I could continue to factor that. And that would give me t minus 2 and t minus 6. Which means the particle is at rest at time 2 and at time 6. So at 2 seconds and at 6 seconds, this particle will be at rest. Okay, moving along. When is the particle moving in the forward direction? Well, that would mean that the velocity is greater than 0. Right? If the velocity of something is greater than 0, it's going to be moving forward or in the positive direction. If the particle is moving backward, then its velocity would be negative. I'd be moving in the negative direction. So what I'm going to do here is I'm going to make a number line. And on that number line, I'm going to put the places where the velocity was 0. So that happened at time 2 and at time 6. Those are the answers to part C. And then I want to look at my velocity function in its most factored form, which is right here. We have 3 times t minus 2 times t minus 6. And what I'm going to do is I'm going to pick a number in each one of these intervals in between my zeros here to figure out if the velocity is positive or negative in those places. So I know that it is equal to 0 at 2 and 6, which means that everywhere else it's not going to be 0, so it's either going to be a positive number or a negative number. And I'm going to plug those numbers in and see what we get. I am going to put another number here. I am going to block this at 0 on the left. I don't want to go left of 0. That would imply a negative time value. So I want to start at 0, put the places where we hit 0, which was at 2 and at 6, and then I could go forever with positive time to the right. So pick some number between really 2 and anything less than 2 that's positive. So I could pick 0 or I could pick 1. And what I'm going to do is I'm going to plug those in here. Now I have this positive 3 out front, so I have that positive value there. Let's say I plugged in 1. 1 minus 2 is negative, and 1 minus 6 is also negative. So if I plugged in 1, what I would have here is a positive number times a negative times another negative, which would give me a positive value there. If I plug in something between 2 and 6, like 3, well, I have, again, the 3 out front is positive. 3 minus 2 would be positive, and 3 minus 6 would be negative. If I multiply those together, I get a negative value in between 2 and 6. And anything to the right of 6, like 7, the 3 is positive. 7 minus 2 is 5, which is positive. 7 minus 6 is 1, which is positive. So I get a positive value out to the right of 6. So how do I use that to answer the question? When is the particle moving in the forward direction or moving in the positive direction? Is it when the velocity is greater than 0, which happens from 0 to 2 and also from 6 to infinity. it would be moving in the negative direction or backward between 2 and 6. Okay, so we're going to use this to help us answer a couple more of the questions below here. The first one is to find the total distance traveled by the particle during the first 8 seconds. The mistake here, I'll talk about the mistake that people make here first before I go through the actual work. So if we want to know total distance, I really don't care about the velocity in terms of plugging those numbers into a velocity function. Okay, what I want to know is what distance did it go. Now, some things that we got here from the velocity function are going to be important to us, but I need to use the position function because I'm talking about how far is a distance, not a speed. Okay, I'm not asking how fast did it go, I'm asking how far did it go, what distance did it travel. So the mistake that people make is if I want to know over the first 8 seconds, some people think, well, if I just know the position of the particle at 8 seconds and I subtract the position of the particle at 0 seconds, I would get the distance that it traveled over the first 8 seconds. The problem with that is that the particle was not always moving in one direction from 0 to 8, right? It was moving forward from 0 to 2, then it was moving backward from 2 to 6, and then forward again from 6 to infinity. So the problem is I can't do this because the particle is not always moving the same direction here. Now, if it were, then I could do this. I could just do s of 8 minus s of 0. But instead, this is just going to actually give me the displacement over the first 8 seconds, which is kind of a physics concept here, not the total distance. So I can't do this. What I have to do is I have to break it into, okay, how far did it travel over this first time interval when it was moving forward? And then how far did it travel backwards from 2 to 6? And then again, how far did it travel from 6 to 8? So the way I'm going to show that is I'm going to say what was the position of the thing at 2 minus the position of the particle at 0. Okay, so it's moving forward from 2 to 0, or from 0 to 2. So position at 2 minus position at 0. And I'm actually going to take the absolute value of this to make sure that I get a positive number here. Then the next interval that we would have is, well, what was the position at 6 minus the position at 2? And again, I'm going to take the absolute value of this to make sure we get a positive number. During that interval, it was moving backwards. So it was moving forwards here, it was moving backwards here, and then it was moving forward after 6, so from 6 to 8. So I wanted the position at 8 minus the position at 6. And if I figure out those distances, so forward distance, a backwards distance, and then another forwards distance, and I add those together, I'm going to get the total distance. And I already have these values for you. I have graphed the position function, which is what you see here. And I went ahead and made a table of values where I plugged in 0, 2, 6, and 8. So for 0 and 6, it's 0, and for 2 and 8, it's 32. So this would be 32 minus 0, which would give me a distance of 32 meters. This would be 0 minus 32, so it moved backwards 32 meters, but again, that means it traveled a distance of 32 meters. And then this was 32 minus 0. I should warn you, you're not always going to get the same values here, so just be careful with that. But that would be, again, a distance of 32. Add all those together, that means that we traveled 96 meters. That particle traveled 96 meters over that first 8 seconds. If you didn't take into consideration the time that it moved backwards, and you just did s of 8 minus s of 0, you would get a value of 32 meters, which is the displacement of the particle. If you think about it moving 32 meters forward, and then 32 meters backwards, and then 32 meters forward again, the displacement is 32. It's 32 meters away from where it started, but it traveled a total distance of 96 meters. Okay. Find the acceleration at time t and at time 3. Well, acceleration is just the derivative of the velocity function. So if we go back up and look at what our velocity function was, that's 3t squared minus 24t plus 36. If I take the derivative of that, I get 6t minus 24. So if I want to find the acceleration at 3 seconds, I'm just going to plug in 3 here. And that would give us a value of -6 meters per second squared. A negative acceleration would mean that the particle is decelerating, right? Slowing down. So when is the particle speeding up and when is it slowing down? So this is a little bit tricky. You cannot just look at the acceleration function. So that's a mistake, a common mistake that people make here, is that we say, well, if I want to speed my car up, I push on the accelerator and that speeds my car up. Or if I want to slow it down, I push on the brakes and that slows me down. But those things are implied that your vehicle is moving forward, right? So if my vehicle is moving forward, that means my velocity is positive and my acceleration is positive. I hit the accelerator, my car will speed up. If my velocity is positive, I'm going forward, and I hit the brake, I would decelerate, but I would be slowing down because my velocity is positive and my acceleration is negative. If you think about flipping your velocity, if you're going in reverse and you hit the accelerator, right, you're going to be slowing down there, okay? So what you need to think about here is when the particle is speeding up or when the particle is slowing down, that means that your velocity and acceleration functions both come into play. And what you need for speeding up is you need velocity and acceleration to be the same. And when slowing down, you need velocity and acceleration to be different. Okay? If we can match up velocity and acceleration, the particle is going to speed up. If we make those different, then it's going to be slowing down. Okay, so here's what I'm going to look at. I'm going to bring back that number line that we had for velocity. So our velocity number line, we said it was at rest at 2 and at 6, and we blocked it at 0 here. And it was positive from 0 to 2, it was negative from 2 to 6, and it was positive from 6 to infinity. Okay, we already created that number line. I'm going to do the exact same thing with acceleration. So I'm going to start it at 0. And what I need to do is I need to figure out, I don't want to use 2 and 6, I want to figure out when acceleration would be 0. Okay, so acceleration would be 0. I think you could set that equal to 0 and solve that. Acceleration would be 0 at time 4. Right, so at 4 seconds, the acceleration is 0. Anything less than 4 plugged into acceleration would give us a negative value. I think that would be easy to see here. We actually plugged in something less than 4 and we got a negative value. So anything less than 4 is going to give us a negative value. And anything greater than 4 would give us a positive value for acceleration. So then when I go to answer this question, I need to match those things up. So when is it going to be speeding up? That's going to be whenever we have the same sign for velocity and acceleration. So I think you can see that that's going to happen from time 2 to time 4, right? So 2 to 4, we're going to be negative in velocity and also negative in acceleration. And then also from 6 to infinity. That would be a positive velocity and a positive acceleration. So 2 to 4 and 6 to infinity, the particle will be speeding up. And then when will it be slowing down? That's when the signs are different, which happens from 0 to 2. From 0 to 2, the velocity is positive, the acceleration is negative, and then also from 4 to 6. From 4 to 6, the velocity is negative, and the acceleration is positive. So those are opposite in sign. So slowing down from 0 to 2 and from 4 to 6. Okay, so when you go through a problem like this and you're asked all these different questions, the key part of this is being able to realize which function do I need? Do I need position? Do I need velocity? Do I need acceleration? And then what do I do with those functions? Do I plug in 0? Do I set them equal to 0? What am I doing with those functions? And if you can figure that out, then this concept hopefully makes sense.